If you're looking for a content comparing the various runtime security agents of the market, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is going to be part of the security playlist where we covered, in fact, quite a lot of episodes, in fact. So we recently explained many of the security agents of the market, including Falco, KubeArmor, Tetragon, but the questions we could have is, which of those agents should I use in my Kubernetes environment? Well, this episode is designed for that, to answer to that questions, giving you some advantage or disadvantage depending on the solutions. If you enjoyed today's content, don't forget to like and subscribe to the channel. To compare each of those solutions, we will basically cover what we expect from a runtime security agent. So we'll start by the actual components that we deploy in the cluster. What are those components? That is normally going to be very similar, but you see there are a few changes depending on the solutions. We'll of course cover the configuration aspects of a given policy. We'll cover the observability exposed by those agents, and then we'll cover more performance aspects such as the resource used by the agents and the potential latency introduced by those agents in our application. From a runtime security agent perspective, we will clearly expect to rely on agents that will be deployed in our hosts in our Kubernetes environment. It means it will be deployed as a daemon set, responsible of deploying the eBPF probes that will collect the various kernel events. So we clearly will have as a core base of each solutions the agents deployed as an eBPF agents. Then depending on the solutions and more on how we configure the solutions, we may have extra components. So for Falco, we don't have any operator, but the actual Falco server, which is a rule-based engine. The daemon set collects the kernel events that are sent to the Falco server, checking if they are matching one of the predefined rules or custom rules that we have defined. Because Falco is not an operator, we don't have any extra CRD. So it could be an advantage when having a big cluster with lots of existing operator. Sometimes CRD is just adding too much pressure to our Kubernetes API. But again, it really depends on your environment. But we will see it also is going to be a disadvantage because it will provide some challenges specifically when designing our policies. For Tetragon, we will have on top of the daemon set the Tetragon operator that will be in charge of configuring the agents. Every time we deploy a tracing policy, the operator will update the rules that is in place on the agents. Meaning that the Tetragon introduces two CRDs, the tracing policies and the trace namespace policy. For KubeArmor, well, here we don't only have one operator on top of the daemon sets deployed, but also a control manager, a relay server. The design of KubeArmor is a bit different. It is moving the observability to the relay server instead of looking at the agent logs directly, we will have to do that on the relay server. In fact, only if you rely on collecting logs, because KubeArmor has an OpenTelemetry receiver that will connect directly to the agents. If you're using the OpenTelemetry collector, in fact, I'm wondering what is the actual role of the relay server. The KubeArmor operator will manage more things than just the policy definitions because the level of events that we would like to have is configured through annotations. So that's the biggest difference compared to the other solutions. So we can define annotations at the pod, namespace, and of course at the host level. And then there's also annotations that could basically change how you would like to react based on a specific annotations regarding the network or the process or the files events that are happening. KubeArmor is providing more CRDs to configure our policies. So one for the namespace policy, one for the cluster policy, and one last for the hosts. Last, we have Tracee. So on top of those daemon sets, Tracee introduced the operator because the configuration, like most of the other agent, is done by using a CRD. In this case, the policy CRD, defining the events that we would like to capture. From a component's perspective, I may only point out that KubeArmor is the only solution adding more workload to our cluster. Maybe it will play a role in the resource usage or optimize the resource utilizations at the overall solutions. But we'll touch about that later on when we touch base on performance. What do we expect from a runtime security agent? Well, there are obviously a few things. So first, be able to detect kernel events, allowing us to create a set of rules that will define a suspicious event from a security perspective. Usually, a suspect event is a combination of various events. So it could be, for example, please alert me every time this process or this execution path of a process is trying to access to a specific file to read or write or touch, whatever, change permissions, or even try to install a non-authorized component. So we clearly expect to be able to capture the right sets of details. Then, of course, with those details, create the rules combining process informations, files, networking, and so on. Produce the event in a human format to be able to parse it and store it in another solution or a backend of our choice. In my case, it will be an Observability backend, of course. To simplify the configuration, it is clearly a must-have to have a predefined rules. And last, of course, when it comes to security, reacting is one thing, but being able to basically do something out of this suspicious event is also very interesting. So being able to create an enforcement rule, that will also be a major differentiation. So in the configuration, let's cover that. We have lots of things to say. So first, all the agents collect processes, file, networking details from their agents. It is usually from the policy that we will define the rule that will filter on the events, on the process, on the file name, whatever, and report that event matching our rule. Falco, from all the agents, is clearly differentiating in this space because Falco is not just an agent, it is a rule-based engine that reports event matching the rules defined. Falco provides its own structure for building the rules. Of course, those rules could rely on syscalls, processes, name, file, container, Kubernetes informations, and more. One thing which is a smart, but could also be considered like almost like a disadvantage, is that Falco load a rule file and also custom rule files at the start of the agents, meaning that we have one or several files defining the sets of rules. With this global approach, it allows us to reuse conditions. So we say reuse the same filters, reuse the same sets of, conditions. So it's very smart because when building security rules, we often pointing to the same directory, same processes, same system calls, so we are repeating the same settings in various policies. The downside of that is that Falco is not providing any CRD, it's not an operator, meaning that our rule needs to be mounted using the config map, for example. So every time we have to add or update a custom rule, we will require to restart the Falco rule engine. What is the biggest difference with Falco compared to the other agent is that it provides predefined rules. Currently, there is only Tracee and Falco, of course, providing default rules. So the most common security events are already defined. We can almost present Falco as a plug-and-play agent. So the configuration is usually the most difficult part using runtime agents. So having this feature increased clearly the adoptions of Falco within our environment. The structure of the rule of Falco is quite simple, and having those predefined rules avoid this complicated onboard journey. But we would need to understand the existing rules, of course, because at the end, you will never create rules if you don't know the language and the how to define those. And of course, by knowing them, we'll be able to adjust them or simply create our new role. Another note about Falco is that it is not limited to kernel event. It has this notion of plugin. So you can receive events from other sources and even build your own plugins using their SDK. So that, I think this is the biggest differentiations with other agents of the market. Next is Tetragon. So Tetragon will be by far the most complicated agents and design experience. But complexity usually comes with power. At the end, Tetragon, you can do, I think, everything. Almost everything which is running on a kernel. To create our policy, Tetragon rely on two CRDs, so the tracing policy for the cluster and the tracing namespace policies for the namespaces. Tetragon follow the logic of eBPF really far, so it allows us to attach various hook points, so using kprobs, uprob, trace points, and so on. So with the right level of expertise, you can report almost everything. But building an event would mean to know exactly the kernel functions, the trace points events, the uprob that we are targeting. And more than just the name of the function, we need to help Tetragon decoding the content, so then we can apply a filtering rule named selector in Tetragon. This is where it gets complicated because we need to know the exact arguments returned and assign the right type to get a human decoding format, so text format, values to build our rule. Then we can apply the filters by applying a selector. Again, here you have many filtering options possible within Tetragon. Currently, Tetragon does not provide any predefined rules. They have few examples of policy, but you would need to define them properly. Because of its flexibility, it is not relying on just a limited sets of syscalls like Tracee or Falco. Clearly, the onboarding journey will require some time, some expertise before having the right sets of rules. We will talk about it in the observability sections. Tetragon is by far the solution exposing many details. But it is actually smart enough because in the configuration of Tetragon, we have the options to define precisely the type of events that we would like to expose in our events. So like I said, very complex, but it has lots of options to fine-tune everything. If you have a good level of kernel knowledge and eBPF, then Tetragon won't be a complicated solution for you. For the other, well, it's gonna be great, but keep in mind this onboarding journey. And when it comes to the enforcements, yes, Tetragon can build enforcement actions, but it can do so many things, not only killing the actual event. So even in the action side, you can imagine to do crazy things, but again, it will require a certain level of expertise. Next is KubeArmor. KubeArmor provides many CRDs compared to the other solutions. The configuration of KubeArmor rules are either based on network details, file, capabilities, processes, syscalls. It has the right sets of filters to limit specific processes or file, but similar to the other agents, KubeArmor required to enable events of those various types to see the details reported by KubeArmor. Once you have the exact structure of the events, you can start building your policies. The various CRDs provided by KubeArmor will target different, of course, type of objects in our cluster. So with the pod or the namespace, the hosts, the entire cluster. This granularity of CRD, I think, could be simplified by having only one CRD, a bit similar to what Tracee is doing. In the policy, we will define what type of events we are targeting. So processes details, file, then create the selector to filter the event on specific path or files or sources, whatever. So it would also be the policy that will define the action. So you can either audit or allow or simply apply an enforcement by blocking the events. Something that is clearly completely different compared to the other solution, KubeArmor, you can adjust how you would like to react depending on a namespace or a pod. And this is possible with the help of the annotations. They have splitted those annotations based on different types, so specific behavior for networking, for processes, for file. Similar to the most of the agents, KubeArmor won't provide any default policy. But KubeArmor has a specific repo with templates of rules. It is a good start, but when looking at this repo, you could face to too many choices, too many rules. So even it becomes complicated to select the one that you would like to use. One thing that I have not tested but sounds amazing is the KubeArmor CLI. That has an options to recommend. It seems that you can ask KubeArmor the type of policy that we should apply depending on what is running, for example, in our namespace. So last tool is Tracee. Tracee provides one single CRD, allowing us to configure the events that we would like to detect in our environment. Tracee policy is based on families of events. So we have the security, the network, the syscalls, and others. The security family includes predefined sets of rules to detect suspicious events, and in fact, Tracee pre-deploy a default policy in our cluster with a large set of those rules. Of course, out of those predefined rules, we can create our own sets of events or rules using the predefined sets of functions or signatures or syscalls that we would like to apply our filters on. Each of those rules are possible with what we named a predefined signature that captures and decode those events, meaning that we can easily filter the event on specific data exposed by the event. For example, in the case of network, we would have the source, the IP source, the destinations, the port, the URL, and more. So again, each signature has its own sets of data. And the amazing thing with this is that, similar to Falco, Tracee has a sort of SDK, allowing us to create our own signatures, helping us to extend the rules that we want to create. So from all the tools, I personally thought that the configuration of Tracee policy was a bit easier, and similar to Tetragon, you can create very advanced rules capturing more than just security events. Similar to Falco, Tracee is not providing any enforcement rules, so it will erase events. To compare each solutions on the observability side, let's split into two areas. The journey to collect and parse the events, and then the metric exposed by the solutions, helping us to keep track on the events and also on the actual health of the solutions. Most of the solution will expose events as logs in the security agent part, except of KubeArmor that will require to enable the KubeArmor logging on the relay server, and in fact it's going to be the relay server exposing those events, or we can simply utilize the open telemetry receiver that KubeArmor has built. KubeArmor and Tracee provide a structured JSON payload for all the events, meaning that the parsing of the data could be easily done by referring to the same attributes of the event. Tracee is providing more details on the events with the data collected by the signature that I mentioned before, meaning that these details will be parsed differently based on the event's signature. So it's going to be a bit similar to Falco and Tetragon that has the event structure really depends on what we're capturing. For example, in Tracee, the HTTP request signature will hold the network communication details, or VFS read will have the details related to the file. So again, the details depends really on the event. Falco and Tetragon are providing lots of details, and the detail exposed really depends on the actual events. So we would clearly have different type of parser based on the event. But one thing which is true for all the solution, depending on the number of policies that you deployed, you will get more or less events, and of course, the quantity of deployments will of course come with a price. Because those agents can produce lots of details on the events, I mean, in this particular case, the events are logs at the end, Tracee and Tetragon allow us to configure them to enable or disable options, providing more or less data in the events. So having these options to adjust the configuration is clearly beneficial to reduce the quantity of data that we would like to deal with when collecting those events. But if you're worried about the volumes of data, you can always turn on throttling, because all of those solutions support event throttling, but you would need to turn it on and configure it. In the most case, we usually rely on logs collected by the log agents like FluentBit or the collector. Tracee is one of the rare solutions providing a fluent forward options, avoiding to read the logs from the agents. KubeArmor, like I mentioned before, has the similar logic by providing this collector receiver that is designed to interact with the gRPC interface of the agents. On the other hand, Falco simplified a lot the event collections with a project Falco Psychic that is designed to pre-parse the events, and push them to a variety of tools. Now, on the metric side, by far, Tetragon is a solution exposing more details on our policy, but also on the actual health of the components, on the operator, and on the agents. Falco and Tracee is also exposing some data about the events and the potential data rejected, but we have limited details on the actual health of the agent. Last is KubeArmor. Well, very disappointed on this area because KubeArmor, as of now, is not providing any metrics. So KubeArmor won't be the good choice if you need to validate that the runtime of your security agent, so KubeArmor, is running smoothly. To be able to compare the behavior of each solutions, I have created a GitHub repo, so here's the links, with the details of the environments and how to run the various tests. In this benchmark, I wanted to measure the latency that each agent will add to the response times of our demo applications. In my case, I'm using the Open Telemetry demo, and the resource usage of the agents. And of course, we'll look at the number of logs collecting during the event, the tests, to figure out the number of events produced. The behavior of the agents will clearly depend, you will see, on the number of events that we have enabled and the number of policy deployed. So I have run several types of tests, so a constant load against the Open Telemetry demo applications with 50 users during 30 minutes. Then a ramp-up test of 2 hours where I'm adding 50 users every 30 minutes. And side of that, there's 2 apps producing some security events on the background. So then there are events produced. Of course, we need different type of tests. So one test with events disabled, if possible, of course. In case of Tetragon, I will still have the execution process details and the exit details because I use the default deployments. And also in this particular case, no policy deployed. You'll have events enabled and no policies to see how it behaves. Events enabled plus policy, and last, event disables and policies. To measure the impact of the latency, I have also executed tests without any agents in the cluster to get the baseline of the application. So let's have a look at the few results, starting with the impact of the latency. So this test has no policy deployed on Tetragon, so the default policy on Tracee and KubeArmor is not generating any events and no policy. So we can see that Tetragon is having 5 milliseconds of latency, extra latency, Falco 10 milliseconds, Tracee almost 11, and last KubeArmor with 15 milliseconds. And again, we need to remind that Tetragon is currently detecting all the process execution exit, and Tracee and Falco has their default policy enabled. Now, what would happen if we include policy plus events? So here in these results, KubeArmor is producing lots of events, in fact, as much as Tracee. We can clearly see that KubeArmor events has an impact on the latency, so we need to reduce the event that we enable in our cluster. And last, Tracee had a policy that is quite expensive, that is tracking the HTTP request and response on the Open Telemetry demo application. And you can imagine that with more traffic, then you get more events. But in this particular test sets, I would say the Falco is the agent that is bringing the less latency. So let's drop the networking events on Tracee and the events on KubeArmor and see the results. So here is the latency produced. You can see that Tracee and KubeArmor still, by disabling those things, are still producing a quite high latency. So let's have a good look at the resource usage of this test. On the memory side, KubeArmor and Falco is around 60 megs, Tetragon about 200 megs, and Tracee 160 megs. On a CPU, Tetragon is consuming only 50 millicore, Falco 100, KubeArmor 170, and last we have Tracee with 230 average CPU. So on the event produced, I was surprised to see that it was not Tetragon, because I was really convinced that Tetragon was going to produce tons of events. So here it is KubeArmor and Tracee that produce the most of the events. We can see that in this configuration, Tracee KubeArmor are quite close compared to Falco and Tetragon. But again, Falco is only using the default pulse rule, so he has a slightly advantage. So the latency observed with Tracee and KubeArmor may be related to the quantity of data produced by those solutions. So I will clearly recommend to fine-tune precisely the number of events or policy that you deploy to avoid having surprises on the latency. That's it for today's episode, comparing all the runtime agents of the market. From all the agents, if we just look at the feature perspective, I think Falco is awesome for beginners by adding their predefined rules. He has quite a challenge when updating those rules and creating those rules. But otherwise, if you're looking for advanced event tracking, I think Tetragon and Tracee are awesome. Tetragon, I would say, won't have to require to build any signatures to build new events or new supports of kernel events. So it has, out of the box, more potentials. In terms of the latency, I mean, Tetragon and Falco are the two agents impacting less our applications. And in terms of resources usage, Tetragon is by far the most efficient resource agents in terms of resource usage. Last, on the observability side, I think that Falco and Tetragon provides enough metrics to understand our policy events, but on the health of the agents, Tetragon excels in these dimensions, providing lots of metrics. So if I had to give a winner in this benchmark, again, it's based on the results that I have from my tests, and I would be very interested to get your feedback from your experience. And by the way, on the poll that I sent, Falco was the most popular agents, and then it was Tetragon. But if I had to give a winner from the different angles that I measured, Tetragon would be the first one for the flexibility, the resource utilizations, and the latency and the observability. I would say from the onboarding it would be more complex, but again, if we just consider what we're capable to do with these agents. Falco will be the second for the onboarding, which is very simple, I would say, the observability and the latency. Tracee will be at the third place due to their predefined rules, the fact that it's quite easy to configure as well. And last, it will be KubeArmor. I think there is lots of interesting points with KubeArmor, but I think with a couple of new features, it will be super powerful. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.